In this video, we'll be going over a GCSE style question that's targeted towards grade 9, and it's about graph transformations. The graph y equals 6 over x is transformed into the graph of y equals 3x over x minus 2. For part A, show that AB over x minus a plus b is equal to bx over x minus a. So this is the identity symbol here, the 3 lines. And so it's like, it shows that it is always equal to. For part B, describe the transformation that maps the graph of y equals 6 over x. The graph of y equals 3x over x minus 2. So we're going to start off with part A first. So this is 2 marks, and so it will be relatively easy. So the first thing that we're going to do is we're going to, on the left hand side of our equation, make the denominators the same. So you have AB over x minus a plus b. And so for b, what we're going to do is we can write b as b over 1, and so we can multiply the numerator and denominator of the part of b by x minus a. This makes the denominators the same for both fractions, and so we can join them together. So this leaves us with x minus a, and then over that is a plus b, ab plus b times x minus a. When we expand this, we get ab plus b times x, which is bx, minus b times a, ab, all over x minus a. The ab's here cancel out, and we're left with bx over x minus a. That's what's been given in the question, and so we know that we have got our 2 marks here. So you can always use questions like this when they give you what you have to get at the end. You can always, it's a great way of having a goal to work towards, and you can work backwards from that if you get stuck. Now we go to part B. Describe the transformation that maps the graph of y equals 6 over x, the graph of y equals 3x over x minus 2. So what we're going to do here is we're going to do something similar to comparing the coefficients. And in this case, we're going to have y equals 3x over x minus 2. And this has the same form as in the previous part, bx over x minus a. Now from here, we can compare our 2 fractions, and we can easily ascertain that a is equal to 2 and b is equal to 3. Now, since we know our values for a and b, we can now plug this into the first part of part A, which has the fraction ab over x minus a plus b. When substituting our values, we have 2 times 3 over x minus 2 plus 3. And so if we just simplify this down, we get 6 over x minus 2 plus 3. Now this is closer to the form of y equals 6 over x, so now it's easier to find the graph transformations. So what we can do is we can split this into two distinct sections. So if we put brackets around our x minus 2 and brackets around just the fraction section, we can now easily get our graph transformations. So compared to y equals 6 over x, we can see that in our x value we have x minus 2 instead. So this means that we're going to translate this graph over in the x direction to the right, so to the positive direction. So we move the graph in the x direction by 2. Next, we have our plus 3. Now this is outside of what seems like a function. So this lies outside of our 6 over x. Okay, so we can treat our 6 over x as f of x, and then we have plus 3 on the outside. So this plus 3 means that we translate our graph in the positive y direction by 3. And so when we do write what our transformation is, we have to write that the transformation is a translation of 2 units to the right and 3 units up. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.